So students, in this lecture, so we will be solving a few previous year gate numericals on design philosophies, whatever concepts we have discussed. Now it's time to implement the concepts, okay? So the first question, it was asked in GATE 2009. It was a 1 mark question from the design philosophy. The question was, for limit state of collapse, clear? The partial factor of safety for limit state of collapse, the partial factor of safety recommended by IS 456-2000 for estimating the design strength of concrete and steel are respectively, right? So the answer is, so you know that I have already told you that for the partial factor of safety for concrete is 1.5 and for steel it is 1.15. So respectively, right? So for concrete is 1.5, for steel it is 1.15. So 1.5 and 1.15, this is the correct answer. Okay. Now the question can be, sir, okay, we have remembered or we have learned the value of partial factor of safety. So, but what is the reason that the partial factor of safety for concrete is higher and the partial factor of safety for steel is lower? Obviously, there should be some logic, right? The logic is because the steel is manufactured in, you can say, factories. Okay, so in factories you have a greater quality control on steel. But as far as the concrete is concerned, so concrete it is casted at site, right? So at site, if you are doing some weight batching or some volume batching, weight mixing, volume mixing, so there can be some error. So that is why to counter that error, what we have done is that the partial factor of safety for concrete has been recommended on a higher side and for steel it is on a lower side. So that is the reason. Okay, so this is what it was a very straightforward question. Okay, so just solve it, right? Now I have looked down all the numericals, previous year numericals. I didn't find any numerical which is, you can say, a bit hard or you can say a bit tricky. Only one numerical I found bit tricky because other numericals they were simple, straightforward numericals. Determine EC, determine split tensile strength, the straightforward formula based questions, right? But this numerical which came in GATE 2014, I found it a little bit tricky. The question was, let us see the numerical. In a reinforced concrete section, the stress at the extreme fiber, in compression, it is talking about concrete, in compression is 5.8 megapascals, so 5.8 Newton per mm square, right? 5.8 megapascals. The depth of neutral axis is 58 mm. The depth of neutral axis is 58 mm. And the grade of concrete is M25. Assuming linear elastic behavior of concrete. Now this is important. Assuming linear elastic behavior of concrete, the effective curvature of the section in per mm is. Okay, now let me read it again. In a reinforced concrete section, the stress at the extreme fiber in compression is 5.8 megapascals. The depth of the neutral axis is 58 mm and grade of concrete is M25. Assuming linear elastic behavior of concrete, the effective curvature of the section is in per mm is. First of all, this question, you know that GATE people, what they are doing? They are mixing various concepts of various topics. So in this question, the concept of strength of materials and the concept of RCC has been mixed together. Right? So what is curvature? So curvature is inverse of radius. 1 upon r is curvature. If somebody of you are knowing, then very well and good. If you are not knowing, I am telling you, in strength of material also it should have been taught to you that the curvature it is equal to 1 upon r. Even if you don't know what curvature is, it is given in per mm. So just by looking at the units, you can determine that it is asking about 1 upon r because r will be in mm and 1 upon r will be in per mm. Right? So let us see how we can solve this numerical. So let us see how to solve this numerical. Okay. So you know the bending or the flexural formula in strength of materials. You must have learned it that the bending or the flexural formula it is given by sigma by y is equals to m by I is equals to E by R. Remember it, right? So this formula will be used. Now the question is, how do you know that this formula will be used? Because in question it was asking me about curvature. and I know that the only formula in which I can determine the radius as well as the curvature is the flexion or the bending formula. Right? Now let us see what is given to me and what do I have to determine. Is sigma given to me? Yes. Sigma in question it was given that the stress at the extreme fiber in compression is 5.8 megapascals. Remember in question it was given. Clear? Now, is y given to me? Yes, y is also given to me. What is the meaning of y in strength of materials? Y is known as the distance of the extreme fiber in compression from the neutral axis. So neutral axis is given to you. Neutral axis is 58 mm. So y will be equal to 58 mm. Simple, right? Now, will this be used to? Will this be useful to me? No, this will not be useful because the moment is not given as well as the moment of inertia is not given, right? Okay. Now, will it be useful? Yes, this will be useful because I need to determine 1 upon r. Now, let us determine these values. So, sigma is 5.8 divided by y. Y is 58 mm. Always take into consideration the units also. So, it is Newton per mm square and it is mm. Clear? It is equals to E by R. So how much is E? Now I told you that E is actually the initial elastic modulus of concrete and it is given in IS code as E is equals to 5000 root FCK. Now the question is FCK given to me? Yes. If you read the question, FCK is given to you as M25. So you know that FCK will be equal to 25 Newton per mm square. Let me put FCK here. So I will get E will be equal to 5000 into under root 25 or you can say 25,000 Newton per mm square will be the value of E. Clear? Let me put 25,000 here. So 25,000 divided by R. R I don't know. This is Newton per mm square. So let me shift it. So I will get R will be 1 upon R will be equal to 1 upon R, which is the curvature. 1 upon R is curvature. Okay. It will be equal to, this will be equal to 1 upon 10 into 25,000. Clear? Now let me write it like this. So curvature will be equal to 1 upon 25 into 10 raised to power 1 to 3 4 minus 4. Clear? Now it will be equal to 100 divided by 25 into 10 raised to power minus 6 divided multiplied with 100. Okay. So it will be equal to 25 4. So it will be equal to 4 into 10 raised to power minus 6 per mm. So this will be the answer. So the option was, I guess it was option number B. So option number B was 4 into 10 raised to power minus 6 per mm. So that is the correct answer. So I hope students that you have understood the concept of limit state method, the working stress method, or in short, the design philosophies. So it was, and one more important thing is that in the question, it can twist it little bit. For example, in this question, it came out with the concept of strength of material as well as the reinforced concrete also. So I hope that you have understood each and everything, and it was really nice talking to you. Okay, so thank you.